Hey everybody, we are live, period one, solving rational equations. Today we're going to talk about just solving the rational equations and then some domain restrictions. Again, because this is live, if you have any questions, you're more than welcome to ask them during it. Just note that everything that you say will be on the video. If you're not, then I'll definitely give you time at the very end after the video in order to ask questions. One of the big things that we're going to discuss today is extraneous solutions. Extraneous solutions is something that you want to just keep a note where if you get a number, essentially if you get a number that'll make your denominator 0 and it's your solution, it's no longer a solution. We call it an extraneous solution. It just means it's a solution that you got that doesn't actually work into the equation. It's also called an excluded value. Solving rational equations, there's a couple different ways that you can do this. One of the big things, though, is multiply each term by the LCD to clear out denominators. That's whenever you have two fractions on the same side. I'll show you an example of that. Also, to solve equations, and then you need to make sure that you check for those extraneous solutions. We'll talk about that as well. But first off, I'm going to go to just something real brief and simple before we even start the notes. I want to show you this setup of a proportion. How would you solve this proportion? How would you solve for x? Think back, geometry. Yep.
You do x times 5 and 2 times 3. So
Yep.
5x equals 6, and then you solve for x.
Good. 5x equals 6, and then solve to get the 6/5. In order to do this, we do something called cross multiplying. I want to show you one more example before we begin, just to kind of refresh your brains. Here's the next example. X over 3 is equal to 5 over 3. How would you solve this? Same way, right? Okay, I'm not trying to trick you at all, but I want you to see this next step. So if I do 3x, and say, for instance, I just don't simplify. 3 times 5. What do I do to get x by itself? I divide both sides by 3. What I mainly want to show you is if you can see that your denominators are the same on both sides of the equation, you can actually cancel them out to start and set your numerators equal to each other. That's something that you're going to see today, and you're going to see in some of your work as well, that's going to make you shorten up your steps like that really, really quick. Okay, so keep that in mind. Cross multiplying is a big thing. And then also, if you have the same denominator on each side of the equals, then you can cancel them out and then just use the numerator. Let's take a look at this first one. Looks like I've got some of the work already done here. We've got x over x minus 3 is equal to negative 2 times x minus 2. Are the denominators the same? No. So we want to cross multiply. So that's the first thing that we're going to do. So x times x minus 2 equals negative 2 times x minus 3. X squared minus 2x equals negative 2x plus 6. And then in this type of situation, you'd want to set it equal to 0 in order to solve, just because of the fact that you're probably going to have to factor. So I'm going to add 2x to both sides, and I'm also going to subtract 6 over. So I'll get x squared is equal to, or x squared minus 6 is equal to 0. And then from here, I can take x squared equals 6. X is equal to plus or minus the square root of 6. check your answer. If I take the square root of 6 or the negative square root of 6 and I plug it into either of those denominators, x minus 3 or x minus 2, am I going to get 0 in my denominator? No. So in this case, this is a perfect solution. That's good. We'll work with that. And then we should be done with the problem. That's all. Questions at all? All right, we're going to go ahead and move to the next one. I apologize. For some reason, I must not have erased a whole bunch of this stuff. Let me erase it real quick. All right, and let's take a look at example number 2. Now, example number 2 is just a little bit different. If you notice on the left side, there are 2 fractions. When you have multiple fractions on the same side, you want to combine the fractions first. So let's go ahead and do that. On this left side here, you're going to multiply by x over x. And on the right side here, 3 over 3. So 5x squared plus 21 over 3x equals 6 over 3x. So very similar to the first one of those extra problems that I kind of showed you as an example. If you look, the denominators are both the same. Because the denominators are both the same on either side of the equality, we can cancel them out, and we can set the numerators equal to each other. So 5x squared plus 21 equals 6. And then we can solve. So 5x squared equals negative 15. X squared is equal to negative 3. X is equal to plus or minus I root 3. Checking back, it does have an I to it, okay? But the denominator itself won't equal 0. You'll just have to make sure that we don't have, we'll have to probably somehow rationalize that at some point, but any questions at all? Example number 2. Okay. I'm going to have you try, why don't we try example number 3. You can already see there that it's no solution, but I'd like you to arrive at that. Why don't you try it out first and see how you can do. So you'll get hopefully to a point where you'll see that x plus 3 is both the denominators. If I simplify, I get x minus 3 equals x. Well, from here, I get negative 3 is equal to 0. So this would be no solution. You'd subtract x on both sides. Questions at all? So far, so good? last example here. I'm sure I've already got some of the work, but I think I did this a little bit. I could show you an easier method, to be honest. So let me go ahead and erase. I want to show you just how this will hopefully play out a little bit. We've got two fractions on one side. So let's combine our fractions. Okay. If you notice, just x squared minus 4, we might want to make this into its factor form of x plus 2 and x minus 2. That way we're not doubling up on the x plus 2. So really on that left side, the only thing that you're going to have to do is multiply by x minus 2. Now, there's a couple different ways to actually solve this. I think one of the easier ones, though, is if you see x minus 2, this is probably going to be the one that's more like in your face for the most part. X minus 2 is on both sides, so I can actually cancel that out. That's erasing it for me, which is kind of odd. So this will just have a 1 under it. So here we'll have x squared minus 2x minus 8 equals 2 times x plus 2. Some of you might actually be able to see that x squared minus 2x minus 8 you can factor. If you can see that and you want to factor it and then try and get something, you could definitely do that. That'll help as well. But if not, this is usually the method that I see a lot of students do. So now we've got x squared minus 2x minus 8 equals 2x plus 4. I'll move everything over. So subtract 2x, subtract 4. X squared minus 4x minus 12 equals 0. And then factor. So this will be x minus 6, x plus 2. So I'll get x is equal to 6 and x is equal to negative 2. So if you're taking a look at this, you see that I have two answers down here in the box. X plus 2 was also in my denominator, which means that if I plug in negative 2 into my denominator anywhere within this problem, I'm going to get 0 within that denominator. So negative 2 is actually not a solution. This is what you would call the extraneous solution. Now, if you factor the x squared minus 2x minus 8 to begin with, if you're one of those people that could see that and factor that, you won't get that. You won't get the negative 2 as your answer.